that same matching of the prototype that was given earlier, same name, same argument, same things, but instead of ending with that semicolon, it goes into the body. So sometimes we'll call these very similar terms, this we'll call the definition or the implementation of a function, and that earlier just introduction of it is called its declaration or its prototype. And they should match, and they're just there to give warning of something coming up later in the file. It initializes a sum to 0. It runs a standard for loop here. Like Java, we tend to count from 0 as computer scientists for kind of a long legacy reason and a little bit of efficiency, where instead of going from 1 to num scores, we actually go from 0 to num scores minus 1. Sure, why not? And then each time through the loop, right, we are prompting the user to give us a score. We're actually reading their score with a getInteger call. And we'll see what getInteger is. getInteger actually is a cs106 function, but it actually retrieves a number that the user types to the console. We add that into the sum, keep going, right? And after we've done the whole thing, at the very end, we're doing a division of the sum by the number of scores to compute the average score that was entered and return that. All right, you see some C++ code. Ask a question.
Did you say why we didn't have inline?
In this case, I didn't have an end line just because I think it makes it nicer for the user. If you say next score and the end line, then you're typing on the line underneath it. And so if you don't put the end line there, it's like you type right next to the question mark. And so it actually, it's just, you know, it's totally an aesthetic thing. And so if I put it there, then it would say next score, and then I would be typing underneath it. And instead, I'm typing right next to it, and then I hit the return, and then the next one comes on the next line. Anything else?
When you're passing the integer, is it passed by reference or passed by value?
Yeah. So it turns out it's passed by value, and I will talk about that a little bit later today. But it is, that's a good question, but a little bit advanced. So just take my answer, and then we'll get to that in maybe 20 minutes if anybody else.
So for every main function, we always have to end it with return 0?
Pretty much, right? You can, as I said, you can put return anything, but as sort of good form, return 0 is a way of saying I successfully completed my job and I'm done. There's Carmel's on the line. What can I do for you?
Could you use a void return type for the main?
In C++, no. So in C, actually, it's a little more lenient about that, and it will allow that. In C++, it wants an int return type. So it's part of the thing. Now I have to decide if I can get this to you without hurting anyone. Oh, so you, the Jessa Lee is the student to go thank for the caramels. All right, so let me just do a little coding with you guys. Just to play around with this and show you the compiler. I'd like to do a little bit of this in real time because I think it's really easy for me. I talk very fast, you might have noticed. When I get going on something, it's really easy for me to just put up a lot of code on a slide and say, here it is, it's all fully formed. And the reality is, of course, is when you're writing your programs yourself, yeah, it's not going to come to you fully formed on a slide all ready to go. And you're going to have to kind of figure out, well, how do you step through making this stuff work? So I'm going to actually do a little bit of development of a program that looked very similar to the one I just wrote, but I'm going to play around with it a little bit to just get at some of the things that are different about C++ and kind of how the tools work and things like that. So this is basically what an empty project kind of starts me off with is I've got, you know, the include for the genlib that I'll always have, my int main that returns 0 and sort of nothing else doing. So I'm going to sit down, I'm going to start typing. I'm going to say welcome and get that going. And then I'm going to move to, let's just do this. We'll play with this for a second here. So some things that I can do. I could say welcome a lot of times. Well, that wasn't really so hot there. There's a little I missing. How about that? You guys can help me when I fail to type correctly. And I say welcome a lot of times. Let's go see this, make sure this works. Okay. Oh, look at that. It doesn't like what I did. Let's see what it has to say. It says cout was not declared in the scope. Endl was not declared in the scope. So this is an error message you're going to see a lot of times in various other symbol names that'll show up there, which is the C++ compiler's way of saying to you, I don't read your mind. You use cout, you used endl. These things come from somewhere, but they're not known to me until you make them known to me. And the way I make those known is that those are part of the standard I/O stream, which is the input-output streams facility for the C++ language. And once I tell it about those things, it's going to be much happier. And it's going to say welcome to me a lot of times. And in fact, I could say this, let's say something better, 106b rocks. And then I'll do this. I'll say, how awesome equals getInteger, and I will So it might help if I move this up a little bit so we can see how awesome, how much do you love 106b. So here I won't use my end-L, so we'll see how the prompt comes out. I'm going to get an integer from them, and then I'm going to use that to write how awesome that many times. Okay, so what does it not like about that? Oh yeah, again, it says get integer, not declared in the scope. This is going to be the bane of our existence today, which is like, yeah, remembering that there are headers out there that have features that we're going to be using, and getting familiar with the ones that we're going to need. There are probably about, 10 total that we'll use again and again and again, and we have to kind of get our bearings about which ones are where. The documentation for all of our CS106 headers is available on the website, kind of in a nice HTMLized version, and the ones from the standard libraries are detailed in the book, kind of on little sidebars on the pages in Chapter 3. So once I get my, actually, how much do you love 106b? I could say, well, I love it 2 times. Okay. I say, no, really, I love it like 1,900. And so, all right, so there you go. 10,000 times later, or if you're not convinced now, I don't know what will convince you. We've seen that. So we've seen a little bit of program, right? We're writing a little bit of things. We're seeing some stuff. It's moving around. Let's see if we can make that averaging thing work for us. Okay, I'll go back to just having say welcome. Which reminds me, just to note that that's what the end-L was doing for me there, which is now the prompt is actually kind of waiting at the end of that line. If I had the end-L, it'd actually be waiting on the next line. So, okay. We're done with that. Whoops. Okay. Let me just put kind of a bogus message here, and then I'm going to say double average equals get scores and average. And then let's go ahead and, well, I'm going to blow off the constant for a little bit just because I'm going to be mucking with it anyway, and I'm not going to use that constant for very long, so I'm not going to worry about it yet. Okay, put my prototype up here. So it knows what I'm talking about, and then I'm going to print out average is average. Okay. So I got a little bit of structure there, and I can even, I'll go in here, copy and paste, really good idea. Like once I've written the function header once, I don't really want to make a mistake. And I can, something that's kind of interesting to know is that, you can always write code that actually doesn't really do what you want to start with, but that kind of lets you test some of the other pieces around it. So in this case, right, I haven't finished fleshing out what get scores and average is, but I can write code around it that says, well, it passes in this number and it does some stuff, right? And right now it just returns 0. It's totally bogus. It's not, solving any of my problems, but it does allow me to test some other part of the code, in this case the main that called it and printed the result, to make sure that connection and kind of other parts are working before I go on to kind of work on this part in isolation. One of the things I'll try to show you whenever I'm doing code is to try to give you a little bit of the insight into how I approach thinking about the code, because I do think that one of the things that really distinguishes somebody who works effectively and productively from someone who spends a lot more time doing it is often just strategies and tactics for how you kind of attack your problem. So I'm hoping that along the way I can kind of share a little bit of the insights that I use to keep myself making forward progress there. So I am going to put in that for loop that I'm looking for, I being less than. I'm really not this bad of a typist in real life, but it's easy to. Okay. So the use of the braces here, right, is what's defining the block structure. So without the open curly brace, close curly brace, right, the for loop and the if and the other statements only grab that next line as being part of the indented body of the for loop. I'm going to go ahead with my next idea. I'm going to put that into sum, and then I'm going to do some things that seem kind of bogus, but we're going to get there. So I'm going to make some mistakes. You're going to watch me make some mistakes. Some of them I'll make on purpose. Some of them I'll actually be making accidentally. We'll see which ones I'm better at finding. So I have my get scores and average. It asks them for the scores. It adds it into the integer, and then doesn't return anything. So first, let's see how the compiler feels about that. So the first thing you'll notice is that compiled. That might alarm you just a little bit, because if you go back here and you look at this code, it certainly seems wrong, right? Anybody want to help me with at least one of the things that's wrong with it? It doesn't return anything, right? Like, wow, that seems a little shocking, right? It's like, it doesn't return anything at all. Well, what is it actually going to then produce? What else is it doing that's a little bit bogus? Sum is not initialized, right? So these are two examples of errors that Java doesn't let you get away with. You may very well remember from having typed in some code like this in Java, that it will complain. If you have a variable and you declare it and you don't initialize it and you start using it, the compiler says, not happening. You need to go back there and give that guy an initial value before you start reading it. Similarly, you fall off the end of a function that said it was going to return a double, you better return a double, right? And every code path, in fact, needs to return a double. You can't kind of bail out early in some cases and leave it fall off the end in others. That it considers both of those right. Big enough errors that it won't let you get away with them. C++ compilers are a little bit more lax. It's crack mom, I told you. It's like, well, if you don't want to initialize that, go ahead. What value does it have then? That's exactly, that's a caramel earning moment there. Exactly what's in memory before. It doesn't make it 0, it doesn't make it empty, it doesn't do anything, nice or clever or helpful. It's like whatever kind of contents were lying around in that particular location, now it's new initial value. So the result will be that we could get some pretty strange results from it. So if I run this thing right now, let's just see, I type in some numbers. I type in, oh, somebody got a 9, somebody got a 67, somebody got an 87. Type in a bunch of numbers, and the average is 0. Right? Well, that was kind of interesting. 0 kind of seems like it had some rhyme or reason to it, but in fact, actually, there's really no guarantee. I can run it again, and I might get very different numbers. Let me make it so I don't have to type in so many numbers because I'm lazy. And I put in 5, 6, 7, 8. Ooh, I got 0 the second time. Well, see, good luck for me. Let's go in and start fixing some of this stuff. So the thing to note is that the compiler isn't nearly as aggressive about being on your case about things, so it does require a little bit more self-monitoring on some of these things, that seeing this result and then kind of going back and kind of figuring out how I got into this situation. So let me get that guy an initial value, and then let me put a return down here. And then we'll see if I like how this works any better. So I put in 5, I put in 6, I put in 7, I put in 6. And the average is 6. Kind of looks good, right? That sort of makes sense to me that the 5 and the 7 kind of cancel each other out. But if I do a little bit more deep testing, where maybe I put in some numbers like 5, 6, 5, 6, right? My average is 5. And in this case, I would think that I would be getting something like 5.5, right in the middle of the average. I go back here and I take a look at what I did, right? And I took sum and I divided it by num scores. What have I failed to do? Cast that thing to get it out of there. So the default, this is the same in Java as it is in C++, is that if you are combining two operands in an arithmetic expression, if they are of mixed type, one is double and one is int, it promotes to the richer type. So if that one of those was a double, it would convert the other one to a double and do the calculation in double space. But as it is, sum is an integer, num scores is an integer, it's doing integer division. Integer division has truncation built into it, so if I divide 10 by 3, I get 3, and that remaining 1/3 is just thrown away. Even though the result is double, that sort of happens after the fact. Like it does the calculation integer space, the 10 divided by 3. It gets the 3 integer result, and then it says, oh, I have an integer here. I need to convert it to a double on my way out, and it takes that and turns it into 3.0. So it doesn't recover that truncated part that got thrown away. If I really want to get a real double result, I got to make one of those a double to force the calculation into the double space. The mechanism in C++ is a little bit different than it is in Java. In fact, the Java mechanism does work, but the preferred form in C++ looks a little bit like this, where you take the name of the type you're trying to convert it to. It looks a little bit like you're making a function call passing sum to a function that will change it into a double. And so by doing this, right, I now have one of them being double. The int on the other side gets promoted. So if I do my 5656, right, that truncated part is now part of that calculation and preserved and pulled out and printed. All right. We're okay on that? Let me change this a little bit to something else. Right now, it assumes that there's a fixed number of scores that you want to do. Maybe what I have is a big stack of exam papers, and I don't actually know how many are in the pile, and I don't actually want to count them ahead of time. I just want to actually just keep entering scores until I get to the bottom of the pile. So I'm going to change this loop to allow me to enter numbers until I say I'm done. Okay, so let's take a look at what that's going to look like. I'm going to get the value here. So I'm going to change my code a little bit. And then if the value is the sentinel, then I don't want to include it in the sum, and otherwise I do. So maybe we'll do this. We'll say if the value